So let's talk a little bit about our triangles first. Last time we met, we talked about finding the area of triangles. And let's say we have a triangle that has a base of 24 feet on bottom and a height over here, let's call that 11 feet. To find its area, what did we do? Okay, there we go. 24 feet times 11 feet. That would make up that related rectangle that would contain that triangle. Then we divide it by 2 because that would be half of that related rectangle. So we multiply that, we get 132. And of course, feet times feet is square feet, or feet squared. What if I wanted to find the perimeter of that rectangle, or that triangle? Perimeter, remember, is distance around, and I find perimeter by just adding up the lengths of all of the sides, all the pieces that make up the outside edge. So we have 24 here. We have 11 feet here, but we don't know this side. Can we find that side? Yes, because our legs are sides A and B. The missing side there is our hypotenuse, so we'll call that side C. A squared plus B squared equals C squared. So we have 24 goes in for A, 11 is going to go in for B, and we're going to find C. So 24 squared is 576. 11 squared is 121. We add those up to get 697 equals C squared, and we have to square root it. So that's going to give us that C equals 26.4. So that means C here is 26.4 feet. So back to our perimeter, we add 26.4 feet. And that all adds up to 61.4 feet of perimeter. One that may have been a little bit new to you is a problem that looks like this. Let's say we have 16 feet here, 31 feet here, and 33 feet here. Now we could check to see if this is a right triangle. Which angle is the only angle that could possibly be a right angle here? I'll call them 1, 2, and 3. Careful. Number 3, because that's the two shortest sides there. So if it's a right triangle, that would have to be the right angle. So to double check to see if this is a right triangle then, those two sides, the 16 and the 31, would have to be the legs. So we'd call them A and B, and the 33 would have to be the hypotenuse, side C. Now notice I'm not going to use an equal sign here because I don't know if they're equal yet. But we're going to put in 16 squared plus 31 squared. That's A squared plus B squared. For C, we're going to put in 33 squared and see what that comes to. Well, 16 squared is 256. 31 squared is 961. That adds up to what? 1,217, I believe. $1,217, perfect. So then 33 squared gives us 1,089. Those are not equal. So this is not a right triangle. Well, if it's not a right triangle, we either have to have an altitude, which would be from one of the corners, one of the vertices, at a right angle to the opposite side, but I'm not going to give you one of those either. What's the other method? Does anybody remember how we found the area of a triangle if we didn't have any right angles and all we were given is the three sides of the triangle? Hero or Huron's formula? Some books call it Hero's formula, others call it Huron's formula. Anybody remember the process? What's the first step? The perimeter. So we're going to add together the 33. I'm going to leave off the feet just for time here. 33, 31, and 16 make 80 feet of perimeter. Then he defined something called the semi-perimeter. What's that about? What's your perimeter divided by 2? So it's 40 feet. Now I've already got them labeled side A, B, and C. That's going to help. Because once you found the semi-perimeter, Huron defined the area to be the square root of S, which is your semi-perimeter of 40, times S minus the length of side A, so 40 minus 16, times S minus the length of side B, so 40 minus 31, and times S minus the length of side C, so 40 minus 33. So this is the square root of 40 times, if I subtract there, that's 24, times 9 times 7. I get 945.93. 245.93. And that was in feet, so that is going to be square feet of area. Yeah, I think I may have said 945, but it is 245.93. So that's a very handy formula because there are a lot of times where you don't have a right triangle and you don't know that altitude. If you were to continue on in the second semester of the class, and actually the second semester for you guys, spring semester is really the second half of the first semester of the course. The actual second semester course for the construction program is a trig course. And in that trig course, we would learn how you could find the length of one of those, of the altitude, or other ways of finding the area without having to use Hero's formula. Of course, then we talked about combining things. So let's say we do a shape like this. I'm going to give you this length here to be 40 feet. This length here I'm going to give you as 28 feet. And this length from here to here I'm going to give you as 24 feet. I want to find both area and perimeter of this. Well, for area, we have to break it up into pieces. There's three things we know how to find the area of: rectangles, triangles, and circles, or parts of circles. So I can cut this into a half circle there, a half circle there, and a rectangle. So I'm going to start out with the rectangle. What's the dimensions of that rectangle? 40 by 28 or 28 by 40, either way works. That comes out to be, what, 1,120 square feet. Next, let's look at this half circle up here. It's half a circle, so I'm going to find the area of the full circle and then just divide it by 2. To find the area of the full circle, of course, I need to know, do I need the diameter or the radius? Careful. For area, I need radius. For circumference, for perimeter, I'm going to need diameter. What is the... I can't find the radius directly, though. I'm going to have to find the diameter first. What is this diameter across here? I heard somebody say 16. Good. So that makes the radius 8, half of the 16. So the area for that is going to be pi. I'm just going to put in 3.14 for pi, times 8 squared, and then divided by 2. So 3.14 times 8 squared divided by 2. Helps if I get the 8 and the 1 in there. Let's try that again. 3.14 times 8 squared divided by 2. 100.48 square feet for that one. And then finally, the third section is going to be this half circle. What's the radius of that half circle? 14 feet. Good. It's 28 feet all the way over, all the way across. So half of that is 14. So that is going to be pi, 3.14 again, times 14 squared and divided by 2. So 3.14 times 14 squared divided by 2. 307.72 square feet. We add those up. We got 0, carry the 1, 5, 12, carry the 1, 8, 2, 5. So 1,528.20 square feet is our area. Perimeter. Well, for the perimeter, we have 28 feet here, plus 40 feet here, plus I need to know this piece here. That's going to be a circumference. That's going to be pi, or 3.14 times, what do I use, diameter or radius for circumference? Diameter. So times the 28. However, that's only half a circle, so we're going to divide by 2. I just used 14 instead of 28, so I divided it by 2 before. So 43.96 feet. So 43.96 feet plus, as I continue to go around, this is 24 feet. Plus, I have another half circle here. So that's going to be pi of 3.14 times, that diameter was 16 divided by 2, which is 25.12 feet. So we add those all up for our perimeter. We have what here? Yeah, I'm going to have to add them up. 161.08 feet of perimeter. Is it all coming back to you now? looked at? Well, one of the other things we looked at was parallelogram. Let's say that this here is 17 feet, and this up here is 25 feet. Can I find the area by doing 25 feet times 17 feet? Say no. No, why doesn't it work? Because when we do the area, we have to multiply two dimensions that are perpendicular, that form right angles. So what I need is this distance across here at a right angle. So if I have to either give you that distance or I have to give you some other information. So if I tell you that this here is 8 feet here, we can now find that because this has to make a right angle. If it's perpendicular, it has to make a right angle in every direction. So this is going to be, if I let this be A and B, because those are the two legs of my right triangle, 17 will be C. A squared plus B squared equals C squared. A is what we're looking for, so I'm going to leave that as A squared. B is 8, so that's going to be 8 squared equals C is 17. So 17 squared. So it's still A squared there. 8 squared is 64. And 17 squared is 289. What's our next step? Subtract 64, right? Get rid of that. We're left with A squared. We'll have to subtract 64 from the other side. Gives us 225. And then we have to square root. A equals 15. So this is 15 feet. So now what do I use to find my area? Somebody be brave. Perfect. 25 feet by 15 feet. Do I have to divide by 2 or anything like that? No, because if I were to chop this piece off over here and move it, that would fill that out. It would make a rectangle that is 25 by 15. So it's a full rectangle. So we don't have to divide by anything. 25 times 15 is 375. Feet times feet is again square feet. So 375 square feet. Talk about volume. Volume is our next step from areas. We defined an area. Let's go over here. We defined an area to be a length that was moved through a distance, a perpendicular distance, to create that two-dimensional object. So that area was that length times the distance. Whether that distance was the width of a rectangle, whether that distance was the distance from the top of a parallelogram to the bottom, it was a length times the distance. Volume is going to be defined very similarly. Pretend this is actually a rectangle. We're just looking at it kind of at a weird angle. A volume is defined as an area that we take and we move in a third direction perpendicular to both of the first two. And you see if I take that rectangle and I kind of pull it through space, it creates a box. And the volume of that box, the size of that box, depends on the area of that original rectangle. We call that the area of the base, because that rectangle is what it was based on, times the distance we moved it. Now, just like with area, that distance is sometimes called height, sometimes called width, but we're going to leave it in our generic formula as area times distance. Bless you. So let's say we have a box that is 16 feet by 14 feet by 10 feet. The base, as we mentioned last class, the base could be any one of those rectangles, but we're going to choose it to be the bottom just to keep it simple. And the area of that base is 16 by 14. Or 224 square feet. So the volume of it was the 224 square feet times that height of 10 feet. So 2,240 cubic feet. Because square feet times feet is cubic feet. The next thing we talked about was surface area. Surface area, remember, we split up into two pieces. Surface area is equal to the area of the base, or the bases, plus something we call lateral area. So lateral area for this one here, we have two bases. We have the bottom and we have the top, because they match up. They're the same. The lateral area is the area that connects those bases. So it's all these rectangles around the sides. And to find the area of that lateral area, the first thing we had to find is the perimeter of the base. So that was 16 plus 14 plus 16 plus 14, or 60 feet for this figure. And the lateral area was just the perimeter of the base times that distance, or that height again. So it's 60 feet times 10 feet is going to give us 600 square feet. So the surface area here is the area of the base, which we already found up here to be 224 square feet, plus another one, because there's a base on top, plus that lateral area of 600 square feet, which gives us 1,048 square feet for our total surface area. So one of the reasons we define surface area like that is because we do run into cylinders. And rather than having to memorize separate formulas for cylinders, we can just use that same process. So let's say that we have an 8-foot diameter bottom, and let's stick with a 10-foot height here. To find the volume, well, actually to find volume or surface area, the first step is always the area of the base. Since this is a circular, the base of this will be the circle on bottom, by the way. So the area of that base is going to be pi, 3.14, times, is it going to be 8 squared? No, what am I going to use? The radius would be 4 feet. So 4 squared. So that is 50.24 square feet is the area of my base. So that my volume is 50.24 square feet times my 10 feet of height. So 502.4 square feet times feet is cubic feet. For surface area, I have the area of my base already. That's 50.24. And yes, there's another base on top. Another 50.24. For my lateral area, I once again need the perimeter of my base. Since the base of this is a circle, that's just a circumference. So that'd be pi 3.14 times the diameter of 8. So 25.12 feet. So my lateral area is that perimeter of the base times my height of 10 feet again, or 251.2 square feet. So that comes up here. So we get 351.68 square feet of total surface area. All looking familiar now? Okay. Do you remember how to do trapezoids? Now remember, we've said really the only thing we know how to find areas of, actually the only shape that area is defined for is a rectangle. So we found the area of rectangles, parallelograms based upon rectangles, and we did triangles based on being half of a rectangle. In fact, we even turned a circle into a rectangle to find the formula for the circle. The trapezoid we did the same thing with. We cut off the corners here, and remember we flipped them up to make a rectangle. Well, the height of that rectangle, or width, is still the 12 inches. It's the length that's the problem. So to find the area of it, we need to figure out the length from here to here, which we know is going to be somewhere between 30 and 18. In fact, it's exactly in the middle, so it's going to be the average of 30 and 18. So 30 plus 18 over 2 is the average of the bases, which ends up being the length of that related rectangle. And we're going to multiply that times the height or the width of 12. So 30 plus 18 is 48 over 2. 48 over 2 is 24. Times 12 is 288. Those are all in inches, so this is inches squared. So because of that formula and because of the way we defined area and volume, and surface area, we can now find the surface area of an object like this. Let's say that is 12 feet there, and this is 5 feet. Over here, we're going to leave that piece off for you for a second. Let's make this 20 feet up here. We'll make this whole bottom be 34 feet. And let's do this. And we'll call this 30 feet of length. So if I want to find the volume and the surface area of this object, I have to find, first of all, I have to decide what the base is. And the base is just the trapezoid here. And the reason that's the base is because that is the shape that I can pull through to the other end, and it matches up with the other end as I pull it through. So I'm going to find the area of that base, so the area of that trapezoid first. I got to find the average of the bases, so it's 20 and 34 divided by 2 times that height of 12. Well, 20 and 34 is 54. Divided by 2 is 27. Times 12 is 324 square feet, I believe. So we have the area of the base. The volume then is, once we found that, is pretty simple. 324 square feet times that length of 30 feet. So it's going to give us 9,720 feet cubed. For surface area, once again, I already have the area of the base, 324 square feet. And there is one at the other end, 324 square feet again. So I need to find the lateral area. And of course, before I find lateral area, I must find the perimeter of that base. Well, I have the 20 on top. I do not know this side here, but I can find it. I've got 5 and 12. If I do a squared plus b squared equals c squared, and I'm going to leave this up to you guys to do that on your own right now, that comes out to be 13 feet. The bottom then is 34. So now we run into this one over here. Well, what do we know about it? We know that this still has to be 12 feet. We know that's got to be a right angle. Can we find that length down there? Sure we can. If the whole thing is 34, this piece is 5, how long does this piece here have to be? This is right angles at every corner. That's a rectangle, isn't it? So it's got to be the same length as the other side, which is 20 feet. So 5 and 20 make 25. Subtract that from 34. This has to be 9 feet. So then this will be 9 squared plus 12 squared equals c squared. And again, I'm going to let you guys work through that on your own if you want to. That'll come out to be 15 feet. So we got 15 feet there. We add that all up, we get, what, 82 feet, I believe, is the perimeter of our base. So then our lateral area is at 82 feet times that length of 30 feet, which is what, 2,460 square feet. So that goes in here for our lateral area. So 8, 0, carry the 1. 1, carry the 1. 3,108 square feet is the surface area of that. So we can find surface area of relatively complex shapes by using that definition of area base and lateral area separated out. Okay, so from here, we've talked about circles and we've talked about pieces of circles, half circles and quarter circles. Let's talk about more refined pieces of those circles. So let's say I have a circle with a diameter of 16 inches. But rather than taking half of it or a quarter of it, I want to take a slice out of this circle. It's 40 degrees. And notice the angle is measured at the center of the circle. We have one radius here, we have another radius here. The angle is the angle between the two radii. How many degrees is a full circle again? 360 degrees. So if I want to find the area of that piece, this piece right here, by the way, is what we refer to as a sector. So the sector area, just like finding the half circle or quarter circle, it is a piece of the whole circle. It is a fraction of the whole circle. So our first step is to find the area of that whole circle. The A with the little circle by it is the symbol for the area of a full circle. That's going to be pi, 3.14, times, is it going to be 16 squared? It's going to be half of the 16. It's going to be 8 squared because 16 is the diameter. So 3.14 times 8 squared should give us 200.96. There it is. And that is inches squared, or square inches. That's the area of the whole circle. So now we can find that sector area. I was going to put SA, but that's surface area. The symbol for sector area is A with a pi wedge drawn next to it. I know mine looks more like an ice cream cone. It is the area of the circle times the angle over 360. The fraction of the full circle is that angle over 360 degrees, because 360 degrees is the full circle. Now, the symbol that they most often use for angle is the Greek letter theta. It's like a 0 or an O with a line through the middle like that. That represents a generic angle or an angle that we're interested in. So for this one, the area of that sector is going to be the 200.96 square inches for the whole circle times 40 over 360. So let's do that out. What do we get here? 200.96 times 40. And the way I'd punch it in is I'd just do times 40 divided by 360, which is going to give me 22.33, I believe, approximately, square inches. So that sector, this little piece of that circle, has an area of 22.33 inches, square inches. I'll have you guys try one real quick. So I've got a sector that's 120 degrees, and we're going to go with a 5-foot radius. Find the area of the sector. Okay, so our first step is to find the area of the full circle. So that'd be pi, or 3.14, times, is it going to be 5 squared or something else? It will be 5 squared because that is our radius. So that gives us 78.5 square feet is the area of the whole circle. Now for the area of our sector, it's the area of that circle, 78.5 square feet times 120 over 360. Which gives us, what, 26.4 4.17 about square feet. If you did 26.2, that's fine as well. How have you got that? Nope. Well, let's try one more, see if we can do a little bit better. So I'm going to give you a circle here with a diameter of 8 inches. And we are going to take a 60-degree sector out of it. Why that's clouding up. Let's try that again. So again, find the sector area. I'll give you a couple minutes to try that one. Okay, so we're going to start out with the area of the whole circle again. 3.14 pi times 4 squared. We got to cut the 8 in half because the 8's the diameter, which is going to give us 50.24 inches squared. Area of the whole circle. For the sector area, it's at 50.24 inches squared times 60 over 360, which is going to give us what? 8.37 about inches squared. How many of you got that one? Good deal, much better. Okay, so we can find the area of a sector. The next thing we can find is an arc length. Okay, an arc, if we're looking at a circle, an arc is any portion of the outside edge, or the boundary of that circle. In other words, it is any portion of the circumference of the circle. And just like the area of a sector, the arc length, or the length of an arc, is defined as a fraction of the whole circle again. So let's say again from the center of this circle, let's say this is 80 degrees. Well, I need to know either a diameter or a radius, so I'm going to tell you that the radius here is 10 inches. Since the arc length is a fraction of the circumference, the first thing I have to find is the circumference of the whole circle. So that's going to be pi, or 3.14, times what number? Not 10 squared, you're thinking area. For circumference, it's just pi times diameter. So it would be 20. Perfect. So that's 62.8 inches is that circumference. He had the right thought, though. So now for the arc length, I'm just going to do AL for arc length. It is the circumference again, 62.8, times that angle over 360 again. So it's the same fraction we used for a sector area. 62.8 times 80 over 360. Yeah, I know I left the zeros off, but the shouldn't affect anything. 13.96 we get. Inches is the arc length. So I'm going to have you guys try one. So I'm going to give you a circle with a diameter of 12 feet. And we're going to look at a section here that is 110 degrees. I want you to find the length of that arc. So I'll give you a couple minutes to find that again. So the first step is to find the circumference of the whole circle, which is going to be pi, or 3.14 times 12. Which gives us 37.68, and that is in feet. So then the arc length is at 37.68 feet times 110 over 360. Gives us 11.51 feet. How many of you had 11.51 feet? A few of you, good. Well, let's see if we can have a little bit of fun with this. I know, fun for who, right? I'm sensing a little bit of sarcasm there. No? Are we able to make this work? Yeah, we'll try. So let's say that we have an 8-inch radius here on a 45-degree angle. I should draw this a little bit bigger here. And I have a 8-inch radius here on a 135-degree angle. And I'm going to tell you that the triangle here oh, this is going to hurt. I'll make that 10 and 10, and this is 14.4 inches between those two spots. And up here, we're going to have 50 inches. And down here, we're going to have 60 inches and 26 inches here. Obviously not drawn to scale. But I want to find the area and perimeter of this. I'm going to give you guys a couple of minutes in your notes. We really have, oh what? If I cut this and make one rectangle here, I've got a little rectangle here, that's 2. The triangle is 3. That rectangle is 4, 5, and 6 pieces. I want you guys to try to find the area and perimeter of that using what we've learned in the last couple of classes. So I'm going to pause this, and I'm going to give you about 3 minutes to work on it, and then we'll talk about it. I'll let you off the hook. We'll walk through this one here. For area, for piece 1, that's just a rectangle that's 26 by 50. So that is going to be 1,300 square inches. Piece 2, that's just a rectangle that is, I guess, as I mentioned, not drawn to scale, 10 by 8. Or 80 square inches. Piece 3 here is a triangle that's 10 by 10, but it's 10 times 10 divided by 2 because it's a triangle, or 50 square inches. Piece 4 That's just a rectangle again. That's going to be 8 by 14.4. So 8 times 14.4. 115.2. Now, for the other two circles, the pieces of circle, how many of you jumped in and tried to find sector areas like what we've just been doing? Okay. How many of you just didn't get time to get that far? Okay. That would work just fine, but if you notice on this one, and I did this to you intentionally, because there's a lot of times when we're dealing with these pieces of circles that if we have circles that have the same radius, these are both 8-inch radii. If they have the same radius, we can put them together to make a bigger portion. So if I have my 45-degree piece and my 135-degree piece, how many degrees does that add up to? 180 degrees, which means it is a full half circle. So we can combine pieces 5 and 6 together and just find a half circle. So we can do pi 3.14 times 8 squared and divide it by 2, which is going to give us 100.48. Now we add that all up. It gives us 1645.68. Anybody come up with that? Cool. Good. I know I cut you a little short of time for the rest of you. I'm sure there's more of you would have got there with a little more time. Perimeter, I know I cut you really short on that. The perimeter here, 50 plus 26 plus 60. Plus, again, I'm going to put the two circles together to make a full half circle. So all I need is this distance around here for that. So I'm going to go ahead and add in this 14.4 right here. And now I got to find the arc length of that half circle. So that's going to be a circumference. The full circumference would be pi 3.14 times, now it was a radius of 8, so it's going to be a diameter of 16, and then divide by 2. So it's 25.12 inches. So we add those all up and we get what? 175.52 inches of perimeter. Okay, well, does Mr. Berghammer have the quiz in there for him to take? Yeah? Okay. I'm going to give you some time to work on that quiz. If you get done with the quiz, has he given you guys the big volume packet, or does he have that sitting in there for you? That's not in there? Okay. There's an area and volume packet that I'll have you guys work on a little bit for Friday. And in there, there's pages 144 through 147. And that's going to be dealing with triangles, rectangles, parallelograms, and stuff like that. Dealing a little bit more with triangles, rectangles, and parallelograms and trapezoids will be pages 156 through 157. So the problems are actually in big gray boxes in that packet. So I'll give you guys our last 25 minutes here to work on that quiz. Make sure you take your time. There's a couple of spots on it that can trip you up. And then get started on that packet.